All right, everybody, today we're looking at the distributive property. This may be something you've seen before. This is a property that kind of allows us to bypass order of operations. Okay, so this will work whether you have a plus or a minus, an addition or subtraction symbol in your parentheses. So I'm just writing both. It's a plus or minus symbol, so it means it could be either. Okay. And normally, what you do in terms of order of operations first is you'd have to do whatever's in parentheses first. But if you want to skip it and do the multiplication first, the key is that you must distribute that A to both terms. So the symbol in the middle stays the same, but you need to multiply the A by both the B and the C. Okay, it's called distributing. So the question is, I guess two reasonable questions come up here. Why would you want to do that, and why does it work? Well, the why you would want to do it is actually pretty simple. A lot of times we want to be able to simplify expressions, but we can't just always follow order of operations. We need some ways to know that, okay, what if I really need to do this multiplication first to simplify this expression? How can I do it? Well, this is the way that you can do it, and we have to make sure that we're doing it in the right way. As far as the why does it work part, that, to tell you the truth, is a little bit trickier, but I think I can explain it pretty easily. So imagine the expression 3 times 6. Another way that we could write this is 3 plus 3 plus 3 plus 3 all the way until we got to 6 threes, right? We could do that, okay? Then what we could do is we could almost just kind of group these individual threes together, and we could say that, okay, this is 3 times 2, and this is 3 times 4. Okay, now if we go back to the other side, the other thing we could do is instead of writing a 6 here, we could write this as a 2 plus 4, as long as we did it first to make it a 6. So from there, we get that 3 times 2 plus 4, or 3 times 6, is equal to 3 times 2 plus 3 times 4. Okay, so I guess that's probably a simple way to explain it. If you're looking for a better explanation, try searching around a little bit. I'm betting you could find some really nice visual explanations for why this works too, but that's the more math nerdy way of doing it. Okay, so here's what I want you to do. We're going to practice using the distributive property just a little bit. In both of these, I want you to use the distributive property, show what that is first, and then simplify if you can. Okay, so looking up here, this would be 6 times 4 plus 6 times 5, because I have to distribute the 6 to the 4 and the 5. Order of operations says I can multiply these together and these together, and then I can add them. Now, was that really any easier than going 6 times 9 and then getting 54? No, not really. We get the same thing either way, so maybe that's not a big deal for that one. But there are others when variables are involved where that will be important. Okay, try doing the same thing down here. Pause, try it out, and then come back and take a look, and we'll see what we got. I'm assuming you've done that. So the first thing I'm going to write is 3 times 2x minus 3 times 4. Okay, remember to keep that subtraction symbol in there. 3 times 2x is 6x, and 3 times 4 is 12. These I cannot combine because they are not like terms. So here it kind of made a difference because I could not do 2x minus 4 first, and this expression, the one that we have over here, to me looks a lot simpler, okay? And it looks like something that's a little bit easier to use. The other thing that we can do, and this is what allows us to combine like terms, is you guys have probably done a little bit of this before. So when you're simplifying this expression, many of you would know that we're allowed to combine the 3x and the 5x and make 8x. But the question is why? Why are we allowed to do that? Well, there's some visual explanations you can give, but the real answer is the distributive property. If we kind of pretend like we did the distributive property backwards, okay, so like look, both of these have an x, we just distributed an x. What if we undid it? That must have meant there was an x on the outside and a 3 plus 5 on the inside. Pause and think about that for a second, or rewind and go back and think about that for a second. That's an important point. Okay, so if they both have an x, we could say that, okay, if we take the distributive property backwards, that means we must have distributed that x to a 3 and a 5. But now look, if you do order of operations on this new expression, you would turn this into an 8. And we could rewrite x times 8 as 8 times x if we felt like it. Because you can do multiplication in any order. So that's actually the real reason why you're allowed to combine like terms. It's actually because you really first are doing this before you get to here. Do you have to show that work? Well, now you're going to. You're going to need to do that for this assignment. In the future, will you need to? No. We're just going to show like terms. But it's really important to understand where this stuff is coming from and that it's not just coming out of nowhere. Okay? So what I want you to do is this. Both of these may or may not have some like terms that you can combine. I want you to try both of these examples, and if you can combine some like terms, go ahead and do it. If you can't, like if there's nothing you could undo with the distributive property to combine like terms, you can just write simplified already. Okay, but I want you to show the work just like I did above when you're trying to combine like terms here. Okay, so pause and then come back. All right, I'm assuming you've done that. Up here, we've got a whole lot of x's. So what we could do is we could first kind of put this 4x over here and switch the order of our addition. Remember, that's the commutative property. Then we could pull out an x and say that, oh, look, we must have just distributed an x to all three of these things. So we're kind of working backwards a little bit. And now we're allowed to add our 8 and 6 and 4 and get 18. Now again, are you always going to have to show these steps? No, you'll be able to go from there to there when you're combining like terms. But for right now, it's good practice to know where that's coming from and to be able to see one of the uses of the distributive property. For C on the bottom, we don't have anything that we can pull out and then end up combining like terms. This one is simplified already because we don't have a bunch of terms that just have an x or just have a y. The x and the x squared don't work really well together. They will not add. They are not like terms. That's it for this one. Hope you learned a little something.